Welcome back. This is John P. Kelleher with Los Menos College. I'm with Fire 102. And again, this is a supplement to the lecture on the PowerPoints you have on Canvas. So let's begin. This is week four. The burning process, characteristics of fire behavior. The process of burning occurs in stages, and it's important for firefighters to understand each one. There are 4 stages: ignition or incipient, growth, fully staged or developed stage, and then finally decay and smoldering stage. We'll go over each one. Number 1, ignition incipient stage. This is where the fire begins. It's how the fire slowly builds momentum or goes out. So imagine if you have some type of cigarette that starts to burning in a garbage can in the corner of a room. That's the ignition temperature, which starting to ignite. Second stage, ignition or second stage, or the growth stage. This is where the fire is in building, becomes oxidized. The speed and growth is dependent on several factors: oxygen supply, the amount of oxygen that's available; fuel, the size of the fire depends on the fuel available; the container size, or the size of the structure or the room that affects its speed; and then insulation. The greater the insulation, the more the heat is trapped. And then 3, fully developed stage. This is when you have fire is flowing. This is when it's no longer in the corner of the room in the garbage can. Now it's up the wall, going across the ceiling, and taking off. Fully developed. It's where all the contents within this container are burning, and it's when the entire area is not burned up, but heated up to its ignition temperature, hence flashover, which we'll go over later. And this is when all the contents of the room reaches ignition temperature. Inside the structure depends on how much air or oxygen gets introduced to the fire. It determines the speed and the extent of the fully developed fire. In an outside fire, the amount of fuel is a determining factor of the fire's size. So what happens after the fire starts to fade, and the 4th stage is the decay stage. This is where the fire has been consumed and begins to diminish in size. When the fire is totally used, the fire begins to extinguish itself. This is a special condition for firefighters called backdraft. Not the movie, but when it's in the decay stage where it actually can go in a blow-up situation. Modes of heat transfer. Heat is a byproduct of combustion. The substance being heated, the distance covered by the material being heated, and the ability of the substance to retain heat will be factors in the spread of the fire. Heat transfers its energy from one substance to another in 4 different ways. Heat transfers, so essentially 4 types of heat transfers. First, conduction; second, convection; third, radiation; and 4th, direct flame impingement. Conduction, number 1, when hot object transfers its heat, it's doing so through conduction. The transfer of heat can be to another object or to another part of the object. The heat is conducted through different materials at different rates. Hence, based on the density, the time, and the application of heat will affect the rate of conduction. Convection. Convection is often considered in wildland fire. Air that is hotter than its surrounding rises. Air that is cooler than its surrounding starts to sink. Remember the molecules. As air is heated, molecules become excited and demand more space to accommodate the vibrations, pushing into one another as they seek space. Best example of convection as wildland fire is when you have a fire at the bottom of the hill, and as the fire goes up the hill, it preheats its fuel as it goes up, and starts to ignite as it rises up and up the hill, and hence that's the most dangerous part of the wildland fire. Third type is radiation. Radiation is when combustion or fire occurs. Light is produced. This light travels by way of light waves. These light waves range from ultraviolet to infrared. An example, the sun heats the earth through radiation or light waves. Radiation is a major contributor to flashover. Heat builds up at upper levels in the room or compartment and radiates heat down into the room. Objects in the room at lower levels approach their respective ignition temperature. And the last section is thermal conductivity of materials. All matter will conduct heat. The ability to heat thermal energy depends on its density. The less dense an object is, the more difficult it is for the heat to be transferred through it. An example is a piece of paper versus a piece of wood. There's so much surface area for the wood and very little for the piece of paper. So what catches fire first? That piece of fire. That piece of paper, sorry. The piece of paper catches quickly. I'm going to show more, maybe show a video on this channel. I'll show some videos if I can. I'll also include that one and go more in detail and showing flasho and the flashover and maybe even backdraft. But this concludes week 4.